Hi, teacher Jerry here. So today, in this topic, we are looking at kinetic particle theory. I think this is very common really that you learn on the lower side. But the overall picture is what are we trying to explain? Because chemistry is about trying to explain. We come up with concept trying to explain what we observe. So, for example, in solid, we know that solid has a fixed shape. They cannot be compressed. So then we call a model that in all because they are orderly arranged, okay, and closely packed. So do take note for arrangement. There are always two things to look for, whether orderly or not, and whether their spacing are they close or not closely packed. This is the part where students tend to lose marks. They may just explain either one of them and then forget the other one. So it's because of what we observe, then chemists come up with model. So if you can think in this way, it may be easier for you to relate, understand, and hence memorize into your system. Similarly, liquid, we know that liquid has, you know, uh, then take up the shape of any container. Why? Because they are disorderly, right? They are, less closely packed, so they can actually slide. Right? When they slide, they take over the shape of one another container. And why gas can be compressed? Because they are very far apart. It's because what we observe, then we try to propose. And when we can make these two connections, learning becomes a bit easier. All right. So it's always about arrangement. It's always about the particle motion. And you can see that the spacing and the attractive force are also related to one another, right? Very strong means they are very close together. Very far means they are very weak, right? Okay, and of course, knowing that when I talk about this is the kinetic energy because it can move rapidly, that's why very high energy, right? Another part of the solid liquid gas is that we talk about the melting point and boiling point. So we got the heating curve, all right, and also from the heating curve we got a boiling curve. So we must first able to identify the physical states, right? When it is, especially when it's melting or boiling, you will have a mixture of the two states. All right. It's common sense, right? When you melt the substance, let's say when ice first melted, it won't just all become liquid. There will be still some solid. Similarly, when you boil water or when water start boiling, there will still be liquid, and of course, some become a gas, steam. So just like you mentioned already, pure substance only melts and boils at one temperature. And just now earlier we also mentioned the impurity will increase the boiling but lowers the melting point. And this is another important common question asked during melting boiling, why the temperature remain constant? So it's like thinking like, if you eat a lot of calories food during the festive season like New Year, Hari Raya, then does it mean that you naturally increase in your weight? Not necessarily, right? Because unless you don't do anything about it, then all the calories will become your fats. But if you do work, so in this case, it's used to do work. Do what? Do work to overcome the force of attraction, right? That's why the heat supply goes to overcome the force of attraction so that the solid vibrate in fixed position. Then you need to overcome until they can slide, until they can move freely apart when they become gas. All right, all these require energy because the more you supply the energy to the particle, it move faster, then you can overcome the force of attraction. Therefore, the temperature remain constant even though we are constantly heating. And likewise, if we talk about cooling, a cooling curve will be something similar. The shape will still be something similar to what we see here. See, it just start from here, then when the liquid condensation becomes when the gas become liquid, the temperature will be the same. So it comes out again, all liquid, then when it freeze, temperature the same. Right? So then the freezing point is the melting point. So it's actually about your 200 plus. Sorry, it's less than 100. The freezing point and the melting point is the same. Same goes to the condensation point and the boiling point. And similarly, you have a gas here. You got a mixture of gas plus liquid. You got liquid. You got liquid and solid during freezing. And then, of course, if you continue, you will be solid. And similarly, do I need to memorize both? Right? Why the temperature remain constant when you're cooling down? Then you will just go opposite. Right? So instead, let me use another thing. Instead of talking about heat is used, we say heat is given out. Right? Instead of overcome, we say when you form, okay, form force of attraction. Right? So can you see the pattern? Can you see the relationship? They are opposite of one another. So we don't always need to memorize both. We know one of them, then we know that the other will just be opposite. Right? So when you come slow down, When it come closer together, the excess energy will be given out, and then you form the force of attraction. And likewise, the opposite will happen. Right? So this is a very typical question that we see in kinetic particle theory. All right. So this is for the first part of this kinetic particle theory, mainly for the O N level science. Catch for the part two on the diffusion, which is mainly for the pure chemistry.